Hello dear friends, today we start about the electric and hybrid vehicle. Myself Ankit B. Joshi. Okay, first of all we start with the introduction. A hybrid vehicle use two or more distinct types of the power such as the internal combustion engine and electric motor. Diesel electric trains using diesel engine and electricity from overhead lines and submarines that use diesel when surface and batteries were submerged. Other means to store energy include pressurized fluid in hydraulic hybrids, moped, electric bicycles, and even electric kick scooters. A simple form of a hybrid powered by an internal combustion engine or an electric motor and the rider's muscles. Every prototype motorcycle in the late 19th century using the same principle. Application: heavy vehicle, rail transport, crane, road transport, commercial vehicle, military off-road vehicles, ship and aircrafts. Okay, then types of engine use: hybrid electric petroleum vehicles. When the term hybrid vehicle is used, it most often refers to a hybrid electric vehicle. This encompasses such vehicles as a Toyota Prius, Toyota Yaris, Toyota Camry hybrids, Ford Escape hybrids, Toyota Highlander hybrids, Honda Insight, Honda Civic hybrids and others. Petroleum electric hybrid most commonly uses internal combustion engine using a variety of fuels, generally gasoline or a diesel engine, and electric motors to power the vehicles. Then energy is stored in the fuel of internal combustion engine and electric battery set. Second one is continuously outboard recharge electric vehicle, short form COREV. Given suitable infrastructure, permission and vehicles, battery electric vehicles can be recharged while the user drives. The BEV establishes contact with the electric rails, plates or overhead wires on the highway via an attached conducting wheels or other similar mechanism. The BEV's batteries are recharged by this process on the highway and can then be used normally on other roads until the battery is discharged. Some of the battery electric locomotives used for maintenance trains on the London Undergrounds are capable of this mode of operation. Power is picked up from the electrified rails where possible, switching to battery power where the electricity supply is disconnected. This provides the advantages in principle of virtually unrestricted highway range as long as you stay where you have BEV infrastructure access. Then next one is hybrid fuel, means dual fuel technologies. In addition to vehicle that use two or more different drives for propulsion, some also consider vehicles that use distinct energy sources or input type fuels using the same engine to be hybrids. Although, to avoid a confusion with hybrid as described above and to use correctly the term, these are perhaps more correctly describe the dual mode vehicles. Some of electric trolley buses can switch between an onboard diesel engine and overhead electrical power depending on condition. Okay, then hybrid fuel mode. Flexible fuel vehicles can use a mixture of input fuel mix in one tank, typically gasoline and ethanol or methanol or biobutanol. Biofuel technologies. LPG and natural gas are very different from petroleum or diesel and cannot be used in the same tank. So it would be impossible to build an LPG or NG flexible fuel system. Okay, these are the example which we have used in the hybrid dual fuel technologies. Okay, then Some vehicles have been modified to use another fuel sources if it is available, such as a car modified to run on autogas and diesel modified to run on a waste vegetable oil that has not been processed in biodiesel. Then after petrol-air hybrid. A French company MDI has a design and has running model of a petrol hybrid engine car. The system does not use air motors to drive the vehicles, being directly driven by a hybrid engine. The engine uses a mixture of compressed air and gasoline injected into the cylinder. A key aspect of the hybrid engine is the active chamber, which is the compartment heating air via fuel, doubling the energy. Then Tata Motors of India assess the design phase towards the full productions for the Indian market and move into the completing detailed development of the compressed air engine into the specific vehicles and stationary application. Then hybrid vehicles. This is the basic figure which can identify how hybrid vehicles works. Okay, these are the batteries, inverters, motor or generator, drive wheels, transmission and output gears. Okay, so in this figure you can just, this is the basic figure of a hybrid vehicle. In this you can see there's two types of prime movers used. One is gasoline engine and second one is battery. Okay, so how it is works. So according to application, hybrid vehicles have classified in two types. First one is series and second one is parallel. In series vehicle you can see that fuel supply from the fuel tank to the engine. Engine generated power transmit to the generator. The generator connected with the battery and battery transmit the power to the motor and motor directly connected with the transmission and transmission transmit power to the wheel. Same way in the parallel technologies. In parallel technologies, battery connected with the motor and motor transmit power with the transmission. Second ways, fuel tank supply fuel to the engine. Generated power from the engine is transmitted to the transmission and both the power transmitted to the wheel. Okay, also you have seen these in this figure. In series, these are the fuel tanks. Okay, and this fuel tank supply fuel to the engine connected with the alternator charge the battery, also transmit the power to the motor. In the parallel system, reservoir connected with the engine, then battery also connected with the motor. These simultaneous technologies directly connected with the transmission. Okay, so then in parallel hybrids. In a parallel hybrid vehicles, and electric motors and internal combustion engines are coupled such that they can power the vehicle either individually or together. Most commonly, the internal combustion engine, the electric motor and gearbox are coupled by the automatically controlled clutches. For electric driving, the clutch between the internal combustion engine is open while the clutch to the gearbox is engaged. While in combustion mode, the engine and motor run at the same speed. Okay, same way such type of the hybrid vehicles is power split or series or parallel hybrids. In a power split hybrid electric drive train, there are two motors, an electric motors and internal combustion engine. The power from these two motors can be shared to drive the wheels via power splitters, which is a simply planetary gear set. The ratio can be from 100% for the combustion engine to 100% for electric motors, or anything in between, such as a 40% for the electric motors and 60% for the combustion engine. The combustion engines can act as a generator charging the batteries. Second, on the open road, the primary power source is in the internal combustion engine where maximum power is required. For example, to overtake, the electric motor is used to assist. This increases the availability power for a short periods, giving the effect of having a larger engine than actually installed. In most applications, the combustion engine is switched off when the car is slow or stationary, reducing the curbside emission. That is series hybrid. A series or a series hybrid is driven by an electric motor functioning as an electric vehicle while the battery pack energy supply is sufficient. With an engine tuned for running as a generator when the battery pack is insufficient. There is no mechanical connection between the engine and the wheels. The purpose of the range extender is to charge the battery. In series hybrids have also been referred to as an extended range electric vehicle or range extended electric vehicle or electric vehicle extended range. So these are the short form of these three terminologies. The BMW i3 with range extender is a production series hybrid. Series arrangement has been common in diesel electric locomotives and ships. Then this arrangement was sometimes referred to as an electric transmission as the electric generator and driving motor replace a mechanical transmission. The vehicle could not move unless the internal combustion engine was running. Supercapacitor combined with lithium-ion battery bank have been used. Then after, plug-in hybrid electric vehicle. Another subtypes of hybrid vehicle is the plug-in hybrid electric vehicle. The plug-in hybrid usually a general fuel electric, parallel or series hybrid with increased energy storage capacity, usually through a lithium-ion battery, which allow the engine to drive on all electric mode as a distance that depends on battery size and its mechanical output. It may be connected to the main electricity supply at the end of the journey to avoid a charging using an onboard internal combustion engine. This concept is attractive to those seeking to minimize on-road emission by avoiding or at least minimizing the use of ICE during daily driving. As with pure electric vehicle, the total emission saving, for example, is CO2 term is depends upon the energy source of electricity generating company. Then the hybrid vehicle typically achieve a greater fuel economy and lower emission than conventional internal combustion engine vehicles, resulting in fewer emission being generated. These savings are primarily achieved by three elements of the typical hybrid designs, relying on both the engine and electric motor for peak power needs, resulting in a smaller size, more for average usage rather than peak power usage. A smaller engine can have a less internal losses and lower weight, having significant battery storage capacity to store and recapture energy, especially in stop and go traffic typical of the city driving cycle, recapturing significant amount of energy during braking that are normally wasted as a heat. This regenerative braking reduces vehicle speed by converting some of the kinetic energy into electricity depending upon the power ratings of the motor and generator. Then after, fuel consumptions and emission reductions. Other techniques that are not necessarily hybrid features but that are frequently found on hybrid vehicles include using Atkinson cycles engine instead of Otto cycle engine for improved fuel economy, We very well know that in petrol engine which is work on Otto cycle, but in hybrid system use in Atkinson cycles. Okay, shutting down the engine during traffic stops or while coatings or during other idle periods. Improving aerodynamics. Improving the shape and aerodynamics of the car is a good way to help better the fuel economy and improve vehicle handling at the same time using low rolling resistance tires. Then tire cause mechanical drags, once again making the engine works harder, consuming more fuels. Hybrid cars may use special tires that are more inflated than regular tires and steeper, or by choice of carcass structure and rubber compound have lower rolling resistance while retaining acceptable grips and so improving fuel economy whatever the power source is. Powering the AC, power steering and other auxiliary pumps electrically as and when needed. This reduces the mechanical losses when compared with the driving them continuously with the traditional engine belts. Then hybrid car consume less fuel than conventional car. Battery are one of two types. First one is nickel metal hybrid and second one is lithium ion. Both are regarded as the more environmentally friendly than lead based battery, which constitute the bulk of petrol car starter batteries today. Lithium ion is the least toxic of the two mentioned above batteries. The toxicity level and the environmental impact of nickel metal hybrid batteries, the type currently used in hybrid, are much lower than battery like lead acid and nickel cadmium according to one source. Nickel metal hybrid batteries are much more toxic than lead batteries. Also, that recycling them and disposing of them safely is difficult. Next, in addition to its smaller size and lighter weight, lithium ion batteries deliver performance that help to protect the environment with features such as improved charge efficiency without memory effect. The lithium ion batteries are appealing because they have the highest energy density of any rechargeable batteries and can produce a voltage more than 3 times that of nickel metal hybrid battery cell while simultaneously storing large quantity of electricity as well. The batteries also produce higher output, boosting vehicle powers, higher efficiency, avoiding wasteful use of electricity, and provide excellent durability compared with the life of battery being roughly equivalent to the life of vehicles. Additionally, use of lithium ion batteries reduce the overall weight of the vehicles and also achieve improved fuel economy of 30% better than petrol powered vehicle with a consequent reduction in CO2 emission helping to prevent a global warmings. Then after is memory effect. Memory effect, also known as a battery effect, lazy battery effect or battery memory, is an effect observed in nickel cadmium and nickel metal hybrid rechargeable battery that cause them to hold less charge. It describes the situation in which nickel cadmium batteries gradually lose their maximum energy capacity if they are repeatedly recharged after being only partially discharged. The battery appears to remember the smaller capacity. It's called memory effect. Then after electric vehicles. Electric vehicles also refer to as an electric drive vehicle use one or more electric motor or a traction motor for propulsion. An electric vehicle may be powered through a collector system by electricity from off-vehicle sources or may be self-contained with a battery or a generator to convert fuel to electricity. Electric vehicles include road and rail vehicles, surface and underwater vessels, electric aircraft and electric spacecraft. Okay. Then electric vehicle sources for to propel the vehicles. For these sources we use connection to generator plants. Direct connections to generation plants as is common along electric trains, trolley buses and trolley trucks. Online electric vehicles collect power from electric power strips but under the road surface through electromagnetic induction. Next one is onboard generation and hybrid electric vehicles. Then enlarge onboard using a diesel engine. A diesel electric locomotive generate onboard using a fuel cell. Vehicle generated onboard using nuclear energy. Also, aircraft carries renewable source such as a power solar vehicles. Okay. Then onboard generation as a hybrid vehicles. It is also possible to have a hybrid electric vehicles that derive electricity from a multiple sources such as onboard rechargeable electricity storage systems called is RESS and a direct continuous connection to land-based generation plant for purpose of on-highway recharging with unrestricted highway range. Onboard rechargeable electricity storage system and a fuel propulsion power sources plug-in hybrids. Okay. Then onboard storage. These systems are powered from an external generator plant nearly always when stationary and then disconnected before motion occur, and electricity is stored in a vehicle until needed. Onboard rechargeable electricity storage system is called RESS called full electric vehicle. Power storage method include chemical energy stored on vehicle in onboard vehicles like battery electric vehicles, kinetic energy storage, second one is flywheel, and static energy stored on vehicle in onboard electric double layer capacitor. These are the methodology which can use to store such type of electricity. I repeated this. Chemical energy stored on the vehicle is onboard batteries like battery electric vehicle. Second, kinetic energy stored in flywheel means IC engine flywheel. Then static energy stored on vehicle is onboard electric double layer capacitor. Then types of batteries means lithium ion batteries. Most electric vehicles use lithium ion batteries. Lithium ion batteries have higher energy density, second, longer lifespan, and higher power density than most other practical batteries. Completing factors include safety, durability, thermal breakdown, and cost. Lithium ion batteries should be used within safe temperature and voltage range in order to operate safely and efficiently. Next, electric motors. For electric trains, forklift trucks, and some electric cars, DC motors are used. In some cases, universal motors are used and then AC or DC may be employed. In recent production vehicles, various motor types have been implemented. For instance, induction motor within Tesla motor vehicles and permanent magnet machine in Nissan Leafs. Then after energy and motors, most large electric transport systems are powered by stationary source of electricity that are directly connected to the vehicle through wires. Electric traction allows the use of regenerative braking, in which the motor are used as a brakes and become generator that transfer the motion of usually a train into the electrical power that is then fed back into the lines. Okay. Then after types of electric vehicles. First one is ground vehicles, means plug-in electric vehicle, hybrid electric vehicles, on and off-road electric vehicles, rail-borne electric vehicles, space rover vehicles, airborne electric vehicles, seaborne electric vehicles, electrically powered spacecrafts. Then after advantages and disadvantages of electric vehicle. First one is environmental point of view. EVs release no tailpipe air pollutants as the place where they are operated. Yes, we are known that these vehicles works on electric base, so we cannot require exhaust emissions pipelines, so no tailpipe air pollutants. They also typically generate less noise pollution than internal combustion engine vehicle, whether at rest or in motion. The energy that electric and hybrid car consume is usually generated by means that have environmental impacts. Nevertheless, adoptions of electric vehicle would have a significant net environmental benefits, except in a few countries that continue to rely on older coal-fired power plants for the bulk of their electricity generation throughout the life of the car. There are special kind of electric vehicle named SAF Tempo in Nepal that help lower the pollutions created by vehicles. These vehicles are powered by electricity, usually charged batteries rather than oil or gas, and currently heavily promoted by government to facilitate the environmental and vehicle management issue. Electric motor doesn't require oxygen. Unlike internal combustion engine, this is useful for submarine and for space rovers. Then after mechanical. Electric motors are mechanically very simple and often achieve 90% energy conservation efficiency over the full range of speed and power output, and can be precisely controlled. They can also be combined with regenerative braking systems that have the ability to convert movement energy back into the stored electricity. This can be used to reduce wear on brake system and consequent brake speed dust, and reduce the total energy requirement of a strip. Regenerative braking is especially effective for start and stop CTUs. They can be finally controlled and provide high torque from rest, unlike internal combustion engine, and do not need multiple gears to match power curves. This removes the need for gearbox and torque converters. Electric vehicles provide quiet and smooth operation and consequently have less noise and vibration than internal combustion engine. Then after energy resilience. Electricity can be produced from a variety of sources, therefore, it gives the greatest degree of energy resilience. Then, after energy efficiency, electric vehicles tanks two-wheel efficiency is about factor of a 3 higher than internal combustion engine vehicles. Energy is not consumed while the vehicle is stationary, unlike internal combustion engine which consume fuel while idling. Then after cost of recharge, then range. Okay, heating of electric vehicles. It could in cold climates considerable energy is needed to heat the interior of a vehicles and to defrost the window. With internal engines, this heat already exists as waste combustion heat diverted from the engine cooling circuit. This process offsets the greenhouse gases external cost. If this is done with the battery electric vehicles, the interior heatings require extra energy from the vehicle's batteries, although some of heat could be harvested from the motor or motor and batteries. The greater efficiency means there is not as much as waste heat available as from a combustion engine. Okay, thank you guys.